Okay, and this final topic is just dealing with prisms. We'll get into spectrometers and how spectrometers work in the next chapter. Um, Spectrometers today use mostly diffraction gratings, but used to they would use prisms, and even still some spectrometers do use prisms. A prism is just a piece of glass shaped in a particular way to disperse light. Uh, and it arises, prisms work because of the index of refraction depends upon the wavelength of light. So this is how prisms disperse light into its different wavelengths. We see here the index of refraction for glass going from 400 to 700 nanometers. It drops, not a whole lot, see 1.53 to 1.51, but over 300 nanometers, the range of sort of the visible spectrum, it drops by 200ths. And that's enough to cause different light of different wavelengths to bend a different angle according to the law of refraction. And we get something that looks like this. So this fact about materials is used to construct a prism spectrometer. As I said, most spectrometers today use diffraction gratings, which we'll talk about in the next chapter. But basically the idea is that it's the same. I send in white light here, and then the different wavelengths of the light are going to change by different angles because of the law of refraction. N1 sine theta 1, or this would be N1 out here, is equal to N2 sine theta 2. So all of these lights have the same theta 1 and same N1, but N2 changes for each wavelength of light, and so it's going to give a different theta 2. So for example, we have our red light here, which is going to have a very small angle of dispersion. It's going to bend not very much. And then we have our purple light, purple here? Yeah, our purple light here that has a much bigger angle, and so it bends more. And this causes a rainbow, right? I mean, we have a little prism in our kitchen, and it makes little rainbows all over the kitchen when the sunlight comes in because of this, because it bends light differently. Now, you can color this rainbow if you like. This was a kindergarten activity. But the colors of the spectrum are Roy G. Biv. You've probably heard this mnemonic, where we follow this order from red all the way down to purple or violet. And also, this would be in our electromagnetic spectrum. If you go back to that plot, this is going to be our low energy up here, and the violet, which is right next to ultraviolet, is our high energy end of the visible spectrum. All right. So you need to know those colors and the order of the colors in which they fall in the electromagnetic spectrum according to energy, which you probably do anyway. All right. And you can color that on your own if you like. This is also how rainbows occur, because the index of refraction of water also depends on wavelength. And so when white light from the sun enters a raindrop, a particular way, it will cause the light to disperse into its colors, the Roy G. Biv. All right, what physical property of glass allows for the creation of light dispersing prisms? I'll leave that with you to do on your own. And I believe that's the end of chapter 6. Most of these problems are fairly simple, but you should certainly work through them. Really, chapter 6 is meant as a prelude to chapter 7, which we'll get into next, and chapter 8.